All right, welcome everyone. We're in the process of letting folks into the webinar today. So just be patient. We'll get started here in just a few minutes. So we certainly thank you for joining us today, wherever you are. So again, happy Friday, and just give us a few moments to let folks join. We can go ahead and get started with just the introductions here, and hopefully everyone will be able to join in as we get started with the webinar. So again, happy Friday from wherever you are. I guess it's good morning, good afternoon, good evening, and then for some of you, it's late good night. So again, we thank you from wherever you're joining us. Welcome, and my name is Dave Cadu. I'm honored to be the CEO of IWCS, and I'll be your moderator this morning. And a few housekeeping items for those of you who are new to the webinar. You are part of a larger audience, so you'll be in listen-only mode, and also we will be recording this presentation for posting on our website at iwcs.org. It should be posted fairly quickly after the webinar, so you can share it with your colleagues. And we will not be sharing the PowerPoint presentation, but I will provide you the email address for our presenter today, and if you want to reach out to him directly, you can do so. We encourage you to enter any questions during the presentation in the chat function. So you can find the chat panel on the right of your screen, and after typing in your questions, hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. Today, our webinar series event is hosted by the Cable and Connectivity Industry Forum. And let me transition here. Here we go. And today we welcome Eric Anderson, a fine presenter who presented his paper back at IWCS 2023 in Orlando last October. Eric is a product development engineer from Prysmian Group in South Carolina, USA. Eric will be presenting his paper on the high fiber density 3456 fiber flexible ribbon indoor and outdoor cable for data center applications. Eric is a product development engineer for one of Prysmian Group's telecom manufacturing plants in Lexington, South Carolina. He has 4 years of experience in the telecom industry. Prior to joining the product development group, Eric was a process engineer at the Lexington plant loose fiber buffering department. Eric earned his master's degree in mechanical engineering from the University of South Carolina. So Eric, thanks again for joining us today and delivering this very important and topical presentation. Thank you.
Yes, thank you, David, for the very kind introduction. I'm very happy to present this presentation today on the 3456 high fiber density flexible ribbon indoor-outdoor cable for data center applications. Before I get started, I'd like to thank the other authors who contributed not only to the paper, but to the presentation itself. Gavin Lynn, Jeff Barker, Brian Risch, and Ben Wells. So with that, I'll go ahead and get started. Yeah, so we know that the demand for fiber optic cable has significantly grown since the start of the COVID-19 pandemic. There are many studies out there that show how much what's the value going to be of the global market size in the years to come. There's one study that shows, and the source is shown in the paper. You can look it up. but that the global market is going to be worth $20 billion by 2028. So that's a very big number. The growth rate is forecasted to be over 15%. So there's not only doing well now, but it's going to be doing well in the future. North America is one particular region that we're expected to see considerable growth, in addition to other parts of the world. Data centers, we know they're going to be growing. They're just the number of data centers is growing as people want to be online more. You have online education, things like that people want to have that facilitate the need for data centers. And then we've all heard of these things: 5G network, FTTH, FTTC, FTTP, which only further the demand for optical fiber. And one thing unique about Prysmian, we have a flex ribbon product line, and that the engineering behind it really allows us to achieve smaller diameters than what you would see in like a flat ribbon design, and really push the boundaries there. So it's a very valuable product line for Prysmian cable. And we have customers that require fire and smoke resistant cables that are suitable for both North America and Europe. North America has their own requirements. Europe has their requirements. They're somewhat different from each other, but oftentimes our customers want to be able to market these cables not only in this part of the world, but also in Europe. All right, so the picture on the right, you can see right here a cross section of the finished cable. It has a very high fiber density, approximately 3.8 fibers per square millimeter. It is compatible with the mass fusion splicing practice, so that is a feature of this cable. The splicing times are a bit longer than what you would see for a flat ribbon, although they have gone down in the last few years because of improvements in the splicing technology. This cable has, like I said, it's qualified for both for sale in North America and Europe. So it has these flame ratings: UL-1685, and FT4, which is a Canadian certification, UL-1666, which allows it to be in a riser application. And then we have CPR, which stands for Construction Product Regulation, and that's pretty much a regulation that allows it to be sold in the European market. And then we have environmental and mechanical testing that was done on this cable and tested per GR-20 and ICEA-696. And as you will see in the next upcoming slides, it did very well. It passed all the testing for ICEA-696, and also for many tests, it passed GR-20 as well. All right, so on to the core structure. So like the title of this presentation says, there are 3456 bend-insensitive fibers, all of which are 200 micron. There's a total of 24 buffer tubes. Each buffer tube has a total of 144 fibers, and there are, in each tube you have 12 fiber flexible ribbons that make up that fiber count. And also another thing is that since this cable is indoor-outdoor application, we need water blocking materials. So we do provide water soluble tape and yarns in each of the buffer tubes in order to water block the cable. There are, as you can see in the picture, it is a 15-around-9 structure, kind of similar to a 288 loose tube. The first layer has 9 tubes that are S&Z stranded around central strength member. The second layer has 15 tubes that are stranded, S&Z stranded around the inner 9 tubes. We do provide water soluble tape around both layers, both the inner pass and the outer pass for water blocking. Another thing is that we have flame-resistant tapes over the outer layer, which serve to help the cable pass the UL and the CPR testing. And one last thing, with regards to the jacketed layer, we use a flame-resistant compound in order to guarantee the burn and smoke-resistant properties. And then we also add 12 water-soluble strength yarns for the cable stiffness. And then on to the mechanical testing. The first test I'm going to talk about is the low and high temperature bend test. The purpose right here is to simulate the mechanical bending and forces in conjunction with the temperature extremes that you will see during the installation of the cable. We do have this procedure, FOTP 37, that we use as a formal procedure that gives us the guidelines for how this test should be conducted. The attenuation limit per ICEA 696 is 0.4. In this graph here, you can see that it did very well. Very low attenuation. We tested at the temperatures of minus 30 degrees Celsius and plus 60 degrees Celsius. Both temperatures, it performed very, very well. And also we didn't see any signs of damage on the cable sample following the test. So that's that. The next test is the cable cold impact test, which is the purpose is to verify the cable jacketing, or excuse me, verify the cable jacket can withstand a low temperature impact. And to do this, we actually take a cable sample and we condition the sample for 4 hours at minus 10 degrees Celsius. We have a weight that's dropped on top of the cable with an impact energy of 2.94 Newton meters. And we repeat that test 2 times, so three separate locations that have to be 150 millimeters apart, showing no damage. And the results of all those 3 tests was that it passed. All right, the next in the mechanical testing is the tensile strain test. This has 2 functions. The first is to evaluate the attenuation increase under bending and tensile loading, and also to measure strain on the fibers as a result of the load. And these next few bullet points kind of summarize the test procedure. We basically take the cable sample, and we wrap it around multiple pulleys. We have a rated installation load of 600 pounds that we have to apply to that sample for 60 minutes. We then reduce the load down to 200 pounds, which we call the residual load, for 10 minutes. And then we're going to remove the load completely for 5 minutes. And then for the first part of the test, we measure the attenuation increase at the residual load, so at 200 pounds, and then with the load removed. And then for the strain part, we measure at the rated installation load, which is 600 pounds, and then we back down to the 200-pound residual load. These 2 graphs on the right, you can see the results. It did very well for the tensile loading part. Very low attenuation, both at the residual and at release. And then on the strain, again, it did very well. You can see the distribution of the attenuation, or excuse me, of the strain of the fibers here did very, very well at both at 600 pounds and at 200 pounds. So overall, very good results for this tensile strain test. All right, the next 4 tests are mechanical testing. These are all going to be done at room temperature. The first is the cyclic flex test, which is going to perform a 180-degree flexure load on the cable. We have a mandrel that we insert the cable into, and then we are going to bend that cable sample back and forth for 25 cycles. That's the cyclic flex test. The next test is a cable impact test, which is somewhat similar to the cold impact test that I spoke about a minute ago, but it does have a higher energy of 4.4 Newton meters. And then we test at 3 separate locations. And then the compressive loading test is a test we're actually going to apply a 220 Newton per centimeter incidental load, and then hold that load constant for 1 minute. And then we're going to remove that 220 load and go down to 110 and apply for 10 minutes. And then at the end of just before release, at the end of the 10 minutes, we will measure the fiber attenuation and see we can check the attenuation of the fibers after that. And then the final part is the cable twist test, where we basically take a sample, we put it into a twist test fixture and twist 180 degrees for 10 cycles, and then measure the attenuation increase after the last cycle. You can see here from the graph, for these 4 tests, they performed very well. Very low attenuation for twist, flex, compression, and impact. And then we have the limit, the ICEA-696 attenuation limit of 0.4 decibels. It did very well in this test. And then our inspectors also looked for physical defects after the tests were completed and did not find any. So for all these 4 tests, it had very, very good attenuation and very, very good performance in regard to the lack of physical defects. All right, the last part of mechanical testing I'm going to talk about is 2 tests. The first is the cable external freeze test, where you pretty much the purpose is to right here evaluate the capability to resist the attenuation increase with freezing water around the cable. Another thing is we want to make sure that cracks don't develop in the jacket when the cable is subject to that environment. So what we're going to do is take a coil sample and basically wrap it, place it inside a water-filled tank. We'll put that into a chamber, and then we'll reduce the temperature of that chamber significantly so that the whole tank is basically has nothing but the cable sample and frozen water in it. And then we're going to raise the temperature to -2 degrees Celsius for 1 hour and measure the attenuation then. The graph on the right, you can see the results. A little slightly higher attenuation than the previous mechanical testing I went over at -2 degrees Celsius, but still does pass the ICEA-696 spec. And then the last test is very basic water penetration. We have a 3-meter sample. We can pre-soak we are allowed per GR-20 to pre-soak one end of the sample at a depth of 100 millimeters for a time of 10 minutes in order to activate the water blocking material. We do need a tap water reservoir with a 1-meter water head connected to the sample. And then for a time of 24 hours, we have to make sure that there is no water penetration on the opposite side. And the results here, pretty straightforward. It did very well. It passed on that test. So that's the end of the mechanical testing, and on to the environmental testing. And this is where, when you have a cable like the 3456, it really is a tough test to do well. When you have a lower free space in the buffer tubes, we all know from just from basic science that when you have a cable jacket at extreme low and extreme high temperatures, that it's going to want to expand or contract, and it can become very difficult in order to pass this test. For this test is a bit different from the mechanicals in that we're going to have a sample probably on the order between 600 to 1,000 meters on a reel with a certain drum diameter. And that cable sample is going to be placed inside a chamber, and then we're going to measure the attenuations both at the at a low temperature, -30 or -40, and the high temperature of +70, and compare those attenuation increases to a reference room temperature measurement. And you can see on the right side here, we tested both A1 and A2 fiber. The A1 fiber just barely passed the 696 spec right here. We had one fiber that was just under the limit of 0.4 decibels. The +70, we did very well. But you can see a difference when we change the fiber types to A2. We see a much better performance at -40. The highest fiber measured right at 0.25 or so decibels per kilometer. And that's really not surprising because A2 fiber has superior properties to A1. So we had the best results with the A2 fiber in the environmental testing. And the next part is really, in my opinion, is the most important testing that was done on this cable. So this is the burn testing, and this is what allows us to market this cable as an indoor-outdoor cable, both not only here in the U.S. and Canada, but also in Europe. And the purpose of these UL and CPR requirements is to limit the flame and smoke production that you would see during a fire. One other point I'd like to make about fiber optic cable is that it is different from copper cable in that it will not it won't start the fire, but the fire can propagate because of the fiber optic cable, and that does present some danger to in the event of a fire to the building itself and the people in the building. So we want to definitely make sure that it can be both burn and smoke resistant if the cable is provided an indoor-outdoor application. And in the UL tests, as I said before, we have the 1666 riser flame test. So this is basically where a set of cable samples is going to be placed inside a multiple-story fixture environment, and there are specific burn requirements that have to be met in order to pass this test. The second one's a 1685, which is a single story test where you have certain smoke requirements and burn requirements as well. And also it also passed the FT4 test as well. And then the CPR testing, we get into these 4 tests right here. 50399 covers the heat release and flame spread. 60332 covers flame propagation. 61034 covers the smoke production, and 60754 covers the acidity. And then this cable achieved Euro class of B2CA. These first 4 items right here govern the Euro class here. The flame spread we achieved was 0.8, which is less than or equal to 1.5, so we met the requirement there. Both heat release and heat release rate met the requirement for the B2CA as well. And also FIGRA right here, we're at 29, which is less than or equal to 150. So we met these 4 items. We did very well, and these 4 items gave us the B2CA listing. And then we get on to the smoke section. The smoke production, we had 1.1 meters squared, and the smoke production rate was 0.01 meters squared per second. Both of those values met the S1 requirement. Right here, we can see the limits, so it did very well there. And again, with acidity, we have 0.3 conductivity and a pH of the material inside the cable being 5.3, and that met the requirement for A1. And then flaming droplets, we achieved D2 because we had more than 10 seconds of flaming droplets on the sample. So that kind of summarizes the results of the burn testing. So we achieved the UL-CUL OFNR riser rating along with FT4 ST1 for the North American certification. And then for the European CPR, we have the results right here, B2CA, S1B, D2, A1. So that's all for burn testing. And then we know that there's like I said in the introduction, the fiber optic cable, the demand for fiber optic cable is growing worldwide. North America is a particular focus of attention for growth. And it's also great for the fiber optic cable manufacturers to have that, to be working in an industry where there is a necessity for your product to be in the marketplace. The number of data centers we know is increasing both in North America and Europe. And it's also desirable to have like this fiber, this design provides fiber optic, high fiber densities and flame and smoke resistant properties. Those things are very desirable. As I showed, this cable met or exceeded the ICEA-696 standard for indoor-outdoor cables. And I think, in my opinion, this is a great contribution to the telecommunication industry because of the fiber count and because of the CPR and UL listings, as well as the performance in regards to the mechanical testing and environmental testing. So that's really all I have to present on this presentation. Thank you very much.
Again, Eric, thank you so much for bringing that to a webinar this morning. It's quite a great technology. 3,456 fiber flexible ribbon is an amazing development, and obviously a lot of complications to meet fire performance and physical performance. So again, I applaud you and your team to generate this technology. Again, I want to remind folks, if you have any questions for Eric, please put them in the chat and we'll address them since we have a few minutes left here. Eric, for the attenuation measurements after the testing, how many fibers are actually measured?
It varies on the test. We are limited to the amount of channels that we have in our lab. I would say for the environmental testing, we're looking at, we do make a fully loaded cable for testing, but we're not going to test all the fibers. I would say probably about half the fibers are tested for the environmental testing, and then the mechanical testing is probably less than 100 for the mechanical testing. So it's really the testing equipment that's the constraint there.
Right. if any of the dry cable fails in the negative temperature cycle, any suggestions on how to make it pass and how to improve it?
Well, a lot of times, like I was saying, with these cables, the free space is really limited. So we have a lot of fibers that are compacted together, and that causes attenuation increase. So one thing that could be done is look at the size of the buffer tubes, making the ID bigger. That might help. Another thing is look at your cable material, because different materials have different properties. Some will expand and contract more than others. So you really need to dive down and look at your dimensions, your materials, and see what can be done there.
Sure. And what kind of screening assessments do you make for the jacketing compounds for these fire-resistant cables?
So it really depends on the application, what the customer wants. If the customer wants just UL, that will influence what properties we will need, what compound we will use, and then same thing for the CPR. And like I was saying, there are different requirements for different parts of the world. So we really need to dive down, look at the properties, look at the requirements, look at what the customer is saying, and make a decision then.
Okay. What's the diameter of the flexible ribbon cables?
It's 30. The overall diameter is 34 millimeters over the jacket.
Amazing.
Yes.
How long do you estimate it takes for a contractor to break out and splice or connectorize this kind of cable?
Yeah, to be honest, I don't have an answer for that. I think that would probably be a better question for an installer. But I will say though that the customers do like the flex ribbon in regards to the installation.
Okay. Have there been any issues with the installation of the cable?
I have not heard anything from the customers, and like I showed in the slides, it did pass a low and high bend test. Also, another thing is that that this does not have a preferential bending axis. It has a central strength member, which is where it derives a lot of its strength. Doesn't have any GRP rods embedded in the jacket, so that is an advantage to the installation. Also, you have to look at and Prysmian puts out the requirements for a minimum bend radius, as well as routing the cable into the building.
Okay. Does the cable tested for aging at plus 85C, is it tested at 85C, or do you have other temperatures mentioned for aging tests of 7 days? So I guess it's, UL standards or international standards for testing.
Yeah, I don't have. We would test at that temperature for aging. For this particular cable, I don't have any results. Just the environmental testing that was shown in the presentation.
Okay. Given the demand for the higher and higher fiber counts and the bandwidth density, along with the maturation of multi-core fiber, would you think that replacing single core fibers with multi-core fibers might be a way to push forward in this technology?
Yeah, that possibly, and again, that would be a discussion that our engineering team would have to have, and perhaps get our customers involved and see and just really look at the benefits, the risks and benefits of using different fiber types in the application.
Good. Um, Before putting the cables in the chamber, uh, what parameters do you measure and focus on so that you can pass the lower temperature?
Well, after each process, we have a buffering, stranding, and jacketing process, and each of those parameters have diameter checks. And then obviously for jacketing, we do the same thing. We'll take a sample and we'll check the outer dimensions, wall thickness, and things like that. We also do an optical optical check after jacketing to get a reference at room temperature before it gets sent to our environmental lab.
Is there a particular parameter that you look for to give you a gauge on whether or not it will be successful in the lower temperature performance?
Really, well, we do have the reference, the optical measurements at room temperature, but really we go by what's worked in the past. We have our our wall thicknesses, tube IDs, and things like that. As long as everything's in the ranges that we want, it should do well.
Very good. Just looking to see if there are any other questions. I don't see any. So with that, again, Eric, a great presentation. It was, and we appreciate the audience for asking a number of questions that confirms the fact that this is really a important technology that we want to learn about. So again, thank you for doing that. Let me go ahead and I will share Eric's email address. Oops, let me get here. I just lost it here. All right. Apologies here. I just lost the screen. There we go. All right. Very good. Okay. So again, you'll see here Eric's email address. And if you want to reach out to him directly, please feel free to do so. Yeah, I'm sure he'll respond accordingly. Each of these IWCS webinar series events are recorded, and as we mentioned, they should be up on our IWCS.org website fairly quickly. I would expect either by the end of the day or early next week, so you can share that with your colleagues and hopefully encourage them to join us in future webinars as well. Our next scheduled technical webinar will be on Friday, June 21st at 10:30 a.m. Eastern USA time. It'll be another very interesting paper delivered by Belden, Cables for Fault Managed Power Systems, and a little bit of information on what is Class 4. So each of you will be receiving a announcement for those for that webinar and future webinar events. So please feel free to share these with your colleagues so that they can join in and register as well. I don't see any last minute questions. So I do want to take a moment to thank our IWCS partner sponsors, including Prysmian, who contribute greatly to the content and the success of the Cable and Connectivity Industry Forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you and our global audience. So again, thank you so much to Prysmian and our other partner sponsors and these leading suppliers in our industry for their support. We are very excited about the program that's coming together for our IWCS 2024 Cable and Connectivity Industry Forum. We met at the end of April and reviewed all of the abstracts that we received, and it is an amazing, high quality set of technical papers that are going to be presented in Providence. So we strongly encourage you to attend and meet with your colleagues and network with the presenters as well as the other attendees at IWCS. We've been conducting these forums for over 72 years, and we are the recognized leader in showcasing new technologies in cable and connectivity products, processes, and applications. So our next conference will be Monday through Thursday, October 14th through the 17th in the Rhode Island Convention Center in Providence, Rhode Island, USA. That's always a very popular venue for IWCS, so we expect a very high attendance. The exhibitor forum, the supplier exhibition, is close to being sold out, so we're very excited about the response. So please watch your inbox, your social media, and of course our website to learn more as the exciting information for the program becomes available. So with that, I want to thank you for spending your time with us this morning, and we hope you have a great weekend. Take care.